So guys, in the previous video, we stated the definition of displacement and the difference between the vector position R, which is a vector, and S, as well as delta S. So we said that R is a vector position. It is the vector OP, where P is the location of this particle at t, at time t. And then we said that S is OP in algebraic form, so it is not a vector, but it is a scalar value, which means it could be positive if this P is at the right side of the origin O, and negative if this P is at the left side of this origin O. And then we said that the displacement is by definition delta S, all right? So the displacement here, as you can see here, guys, it is S prime minus S. Now, what is S prime minus S? S prime is O, P prime. So I have always to start by O minus S, which is O, P. All right? So this is delta S. It is S prime minus S. And then, guys, we said that there is another parameter that is called ST. And this ST is different than delta S. So what is ST? ST is by definition the distance traveled. And it is a positive value that represents the total length of the path over which the particle travels. So what's the difference between displacement and ST? In fact, guys, displacement is independent of the path traveled by this particle. It's independent of the path followed by this particle. If I am at time t, then S will be OP. If I am at time t prime, then S will be OP prime, and I'm not concerned about the path followed from P to reach P prime. It doesn't matter for me. It doesn't matter in the definition of displacement. Delta S is S prime minus S. It is OP prime minus OP, even if I go back and forth 1000 times to reach P prime. If at T prime I am at P prime, then delta S will be S prime minus S, regardless of the path followed by this particle. And this is not the case for the distance traveled. The distance traveled, ST, depends on the path followed by the particle to reach P prime. Which means, guys, if I am at P now, and I need to find ST, followed by me to reach P prime, I have to find the whole path followed by this particle or by this body to reach P prime. It's not only OP prime minus OP. For example, guys, let's take this example right here. In this example, I have a T that the particle is at a location P. Now at T prime, this particle arrives to P prime. What will be delta S? Delta S is OP prime minus OP, which is here negative, because in fact this particle is going to the left side of O. It is going in the left side. So that's why, guys, here delta S is negative. What about ST? First of all, ST is always positive. It is a distance, all right? Guys, delta S doesn't depend on the path. But in fact, this particle is going in this way to reach P prime. Which means, guys, that the distance traveled from P to P prime, ST, is equal to this whole distance, which is much greater than the absolute value of delta S. Why did I say the absolute value of delta S? Because delta S could be positive or negative, and this depends on the direction of the motion of this particle. Here, delta S is negative. ST is always positive. and st is always greater or equal to this delta s. If P followed this path only to reach P prime, in this only case, st will be equal to delta s. So this is the difference between st and delta s. In the next video, we're gonna start by the velocity. Thank you.